Eagle Point.
Eagle Point? Okay, Sam's Valley, that's a dry place. Grants Pass?
Phoenix.
Phoenix, okay, near in. Anybody else?
Upper Applegate.
Upper Applegate?
The Dalles.
Okay. Oh, way up. We got a lot of water up there. Okay, and then specific interest. Are you in it? Are you here to learn about just supplementing an irrigation supply for gardening or for fire suppression, for potable water perhaps? Show of hands for just fire suppression. How about, that's about maybe 6 people. Show of hands for people mostly in irrigating, garden, landscape, that sort of thing. It's almost everybody. And that's probably what in my career, what I saw people being most interested in. Okay, so these are resources that I'm going to be referring to throughout the presentation. A lot of the images you'll see in the handout are printed from these. I tried to cite them where I could, where I didn't just know that I didn't usually make it up. If it's a photograph, it's probably mine. And I have some of these books on in front here if you're interested in looking at them afterwards. Okay, so we're going to talk about the things you do before you invest in a rainwater catchment system. And this is something that Angie Boudreau, who used to work for Soil Water Conservation District here, made me promise to do when she dragged me into this business 13 or 14 years ago. She said, don't just put a tank under a gutter. Make sure people do all the other things first because they're going to save a ton of money. And so the first dozen slides or so have nothing to do with tanks and collecting the water. It's how you make the rainwater that falls on your land do you some good, or more good than it does. Then it's determining the water demand, estimating your potential collection given your surface sizes, your roof surfaces, then all the elements that are part of a rainwater system. For example, the roof, gutter, a first flush device if you need to use it. Not everybody needs one. A filter of some kind that takes the leaves out of the gutter or out of the water stream. And then the conveyance, the piping that takes you to the tank. And then the way you get the tank to the point of source, whatever point of use, whatever that is, whether it's going to be a garden or a fire hydrant. So we'll take each of those elements in turn and talk about your options. Okay, so let's have an exercise. How much water do you manage is the question. And I imagine most of you have, do people here have acreage or they have lots? Who's a rural person? Who's an urban person? Rural person, raise your hands. That's a lot of people. Urban people, raise your hands. Okay, so it's about a third urban, mostly rural. So if we're talking about acres, that's a lot of square feet. 1 inch of rain will give you 0.6 of a gallon roughly per square foot. So if you multiply that times that number of square feet, that's the number of gallons of water you get per inch of rain on your acreage. And the reason I asked about where people lived is that rainfall, precipitation in general in Jackson County is widely distributed. It can be anywhere from 10 to 35, 40 inches, depending on where you live. So if you know what your rainfall tends to be, and I'll just take an average 20 inches, it's over 500,000 gallons per acre. It's a lot of water, right? And most of it doesn't fall on a roof, right? It falls on the land. So we're going to talk a little bit about what you can do with that. Just for reference though, an acre foot, that's what irrigation rights people have. Does anyone here have irrigation rights to a ditch or anything like that? Okay, so your allotment is measured in acre feet probably, and you may have half an acre foot or a full acre foot. That's how much water you have access to. So the comparison is pretty dramatic, right? So one of the things you can do is install berms that would catch water, slow it down if it's coming down a slope, and have it gather at the base of a tree or grouping of planting of some kind. And if it has a spillway, the water could continue down the hill if you want to do that. Plant another one of these further downhill. This slows the water down and lets it infiltrate deeper so it doesn't either run off your land or stay on the surface where it could evaporate. You could do a mulch basin, which is very common in gray water design, where your gray water point of where the pipe ends would go into a basin where it would just drip down to the base of the tree. You could do things like this, where you put in a check dam on a dry stream and just slow the water down. You're not trying to create a pond. You just want to slow the water down so it infiltrates the soil where it might do the roots of the plants around it a little bit more good. And you could do something like this, which is a a berm that doesn't have an outlet. And you'll see these in Ashland. I think there are other cities in the valley that have done this as well. But this parking lot here, all the water that sheets off of it goes into the basin before it hits the street. So it doesn't go into their stormwater system. There's another shot of it. So do things like this first. If you have tractor lanes or paths or driveways and you see erosion on them, consider grading it so that the water is spilled in a place that you want to control it, where it goes to a group of trees that you've planted perhaps. These are called, on trails are called grade dips or nicks, but you could do these on roads as well. And that just controls the direction and flow of the water so it doesn't erode your driveway or your path, but you can control its direction and make sure that it goes to a point of what you feel is a beneficial use. And then native plants. You could put native grasses in. This is a lawn. It's one of the Western fescues, I forget which one, that are typically drought tolerant, fire resistant, and if they do burn, they are often also fire adapted. So they found some way to regenerate after fire. So if you can plant things that are not likely to burn or don't burn very hot or drought tolerant, you're a little bit better off than if you plant a landscape that needs a lot of water. So what helps rain soak in? Let's talk about, or what does it cost to have rain soak in? Is anyone here in landscape, as a landscape professional? Okay, I might ask you for some assistance with this. If I had, let's say, an acre and I wanted you to help me design it, what would your fee to help design that be if my goal was just to build some berms and basins and things like what you saw on the previous slides per acre?
Actually worked on an acreage.
Okay.
I did most design work in Portland.
Okay.
Smaller.
Just from some construction experience, you would get some small earth moving machines out there and you would charge a certain amount per day in addition to fuel.
Okay, I've anticipated part of that. I know that my cost for someone operating a grader or any type of heavy equipment is about $1,000 a day. I'm going to guess at a design fee. Let's say it's $1,000 for an acre for something fairly simple. And planting and seeding, I might go to Plant Oregon or Shooting Star and buy some native plants, and it might cost me another $1,000. Buy a bunch of seeds and things, another, part of that $1,000. Other might be, I might want to add an irrigation system just to keep things wet while they're growing up before they have enough root in them to, but by the time I turn off that water, they can make it on their own. So let's say we have a $4,000 cost here to do some of these basic measures to help the water infiltrate into the soil better. This is cost per acre. Now, remember that number of about 5 million gallons per acre of rainfall? If we divided that 5 million gallons into that $4,000, does anyone have their calculator open right now? What is the cost per gallon to spend $4,000, invest $4,000 to control or do a better job with what looks like 5 million gallons of water? I'm sorry, it wasn't 5 million, it was 500,000. I forgot what the number was. 535, right. So what is that? What's the cost? Someone's got to be quicker with a calculator than I have in my head. 535,000. Yeah.
You want dollars per gallon?
Dollars per gallon.
Man, I'm coming up with a tiny number.
Exactly. It's
Yeah.
less than a penny. It's 8/10 of a cent or less.
2 times 10 to the negative 1.
Yeah. It's a tiny, tiny, tiny number. And so before you spend a ton of money, 75 cents to close to $3.50, $4 a gallon on a rainwater catchment system, think about all the things you can do that are much less expensive. Now, the disadvantage of all these measures that you do to improve your landscape so it'll let that water infiltrate better is that you don't control when you get to use it. It's not available to you in July and August and September. That's the downside. But if you do these measures, you might not need to irrigate in June, and you may be able to stop irrigating sooner because the rain that falls in October might make a bigger difference for you. So you shorten the time of the window that you need to irrigate. Okay, designing a system to support your needs. Storm surge retention is very common in big cities. We don't probably have a program yet in the Rogue Valley, but I know they do in Seattle and Portland, where they're actually paying people to put a tank in their backyards to keep water from overwhelming their city streets. Gardens and orchards, people mentioned that. Livestock, anyone here looking for, okay, we have some livestock, right? Wildfire suppression, pretty big issue for most of us. Flushing toilets, anyone interested in that? Okay, good. And then drinking water, how about potable water systems? Yeah, okay. That's a complicated one, but it's doable. And then the other might be something like landscape features like pools or having water fountains, things like that. How we use water. I got this from Julie Smitherman, who's the Medford water conservation specialist, I think is her title. But the important thing to note here, oops, wrong button, is that over half of the water that we use on an annual basis, family of 4 in America, over half is for outdoor use, irrigation. Most of that's in the summertime. In the average American family, it's not in here, but the average American family consumes about 100,000 gallons of water in a year, average. So when you're calculating your estimated needs, kind of keep those numbers as a sort of bracket where you think you might need to go with that, because that's going to affect your storage, how much storage you need. Yes, Annette.
Is that typical family use 5,000 in the winter, 25 in the summer, per day or per year or per month?
That's a good question. Julie sent me the slide and I didn't ask that.
Oh, okay.
I can always count on you to
Here
ask the
isn't
question.
5,000 gallons a day. No,
What's that?
it's not going to be 5,000 gallons a day.
No, it's more like, I would say monthly or annually. So local precipitation, this is a pretty typical profile. This is from Ashland's North Mountain Park Nature Center where they have a gauge. A lot of us have weather stations. Raise your hand if you have a weather station where you keep track of this stuff. So a couple of us do this. It's a lot of fun. I really recommend it. Whoops, and again, wrong slide. Did that wrong. So our challenge is we get all of our rain in the fall and winter, but we need it in the spring and summer and into the early fall. That's our problem. If we lived in the Midwest or somewhere in the South where they get rain every month reliably, we could all deal with 2,500 gallon tanks. They get filled up every month and we just empty them, and they get filled up and we'd empty them. But we don't have that luxury. All of our rain comes at once, so we need to fill up a larger system if we want to supply a lot of water in the dry period. Because of our topography, get the button right here, we have a lot of varied rainfall. I understand that up along this area, as you're approaching the Cascades, you get more rainwater than if you're in the valley. Parts of Sterling Creek and the drainages just south of us here are in the 13 to 14 to 15 inches a year category. But over here on Thompson Creek, I have friends who report 30 to 40 inches a year. So it's a lot of variety based on topography. If you have an idea of what you're getting in your area, ask a neighbor who has a rain gauge and they can tell you. That would be really helpful because that's going to help you planning on the next steps. A little bit about permitting. This is not a fun subject. It's kind of dry and boring, but first question is it legal to capture rainwater in Oregon? The answer is yes, it always has been. It's never been illegal. It just has to come off of a roof and it has to go into a tank. It can't go onto the ground and then into a tank. It has to go into a tank directly from the roof. So irrigation system only, if that's your only use, then you do not need a permit in this county, but there's some conditions on that. If it's a potable system, you have to follow all of the requirements in Measure K or Appendix K, which are pretty stringent because they don't want people getting sick, and that makes sense. And we'll get into what those are. Continued. Non-potable system for cooling, evaporative cooling, or for using the flush toilets, you need a plumbing permit. And there's a whole code on how to do this. Your plumber would be familiar with that. You can download the code if you can find it. They hide it on the internet. Electrical equipment, if you're going to power that water, pressurize it in any way, and you want to have that be hardwired into a panel, it has to be, you have to pull an electrical permit for it as well. If you're lucky, you can use gravity to do all your pressurizing and you won't have to worry about that. Anything larger than 5,000 gallons, a single tank larger than 5,000 gallons has to have a building permit. And the reasoning is that the county's concerned that these things are getting to weigh something like, I don't know, 40, 50, 60 tons. And they want to make sure that the ground underneath them is going to support it, that it's got the proper pad, that it's not situated so that in an earthquake, it might roll down onto your neighbor's property. So there's a reason for that. But if you had a series of 5,000 gallon tanks all linked together, let's just say there's some ambiguity there. Any facilities that are in a floodplain have to go through a review process. And most of us probably aren't in a floodplain, guessing. The Soil Water Conservation District is a fantastic resource, and I highly encourage you to explore working with these guys. They have grant funding and grant writing assistance, and Cora Mousseau, here's her contact information, it's in the handouts, is a fabulous resource on this. She talks about conservation all over the county, so she's really a good person to be talking to about this. You might get tanks at a discount, you might even get a huge screaming deal on a tank. Okay, and if you live in a city like Ashland or some parts of Jacksonville, you may need to comply with some historic district issues. They don't want a big plastic tank in the front yard of a old mansion of some kind. Typically, there's a height restriction, can't be over 6 feet. They want to make sure that there's enough clearance in the side yard so fire department personnel can pass through with hoses in case they have to get to the backyard. But those are really the only requirements. They don't want to discourage people from having a rainwater collection. There's just some conditions that they want to make sure people are aware of. Okay, so now we're going to jump into the actual rainwater collection systems. An overview one more time of all the things in here. We're going to start on the roof, look at gutters, downspouts, any type of first flush device for filtration that's on that downspout, the tank and the types of tank options you have and the ways you get the water from the tank to the point of use. Okay, so all of these roofs have the same footprint, but they have very different surface areas. The rain doesn't care what the shape of the roof is. It only cares about the footprint. So all of these actually have the same footprint. They collect the same amount of rain, even though the surface areas are very different. And the easiest way to determine what your footprint is for your roof, if you don't have your building plans and you don't want to get on a ladder with a tape measure like I used to do, is you go to Google Earth. And they have this really cool feature up here in the box, the toolbox that has a tape measure on it. You click on it and you can go from, whoops, I got to stop doing that. You can go from that corner to that corner, to that corner, to that corner, and it'll give you a graph and tell you the square footage. Or it'll at least give you dimensions so you can calculate square footage on your own. And it's a great tool. I believe it's still free. I can't remember. It's been a while since I used it.
It is.
There are actually roofing programs that if you know a roofer, they could do this for you as well. So question, exercise here. How large is your roof? Does everybody here have an idea of how big the roof is? Okay, take just 30 seconds and take your square footage of your roof size, multiply it times 0.623 times the average rainfall depth that you believe you have in your area. And I want to hear some numbers. I want to hear what you think your roof can collect. 12,500 gallons in a year. Okay, anybody else? 41,000 gallons in a year, okay? I'm going to throw in my number. It's 55,000 gallons. I have a house, a garage, a couple of outbuildings, a shop, a bunch of stuff. They're all connected to my system. I collect a lot of water. I could collect a lot of water. I wished I had that many tanks. Anybody else have numbers?
10,800.
Okay.
That's without the safety factor.
Okay. The safety factor is for water that splashes off the roof or might get lost in transport.
Subtracting 5 to 10%.
Yeah, you could just multiply it times 0.95 and you're good to go. So, but most people are startled by the amount of rain they could collect in a year off their roof. That's a big number for most people. And it's way more than is going to fit in the typical plastic tank. And that's kind of good news. I mean, it's not like you it's not a worthy thing to do. It just, you need a lot of tanks to collect all the water that comes off of a roof. That's your collection system potential. Now moving on to the type of roof. Water, the cleanest water that can get into the tank is coming off the cleanest roof, and that would be a metal roof. There's just less stuff on the roof, grit, pieces of wood, whatever that might get caught up in the water supply and then get deposited either in your gutter or in the tank itself. So if you had a choice and you had roofs that had metal on them, that's where I'd put a rainwater collection system. Followed by tile, which is also hard surface, doesn't really shed material off of it, but has lots of nooks and crannies for moss and things to grow, and that would end up in your water supply. Followed by shake, which is a bad idea in a fire-prone area, but it's also cleaner than asphalt shingle, which is unfortunately the most common roofing system that we have in anywhere in America. The challenge we have with asphalt shingle is this is what I apologize, I have very big thumbs and a slow memory for how to do this. There, you get all that stuff. The roof is shedding constantly, and that winds up, if you don't filter it out, winds up in your tank. There are some hydrocarbons that also leach out of the surface of the shingles, which make it unsuitable for potable water. But a lot of people use these kinds of roofs for irrigation, fire suppression, and everything else. So if you have this, don't just go out and get a new roof because of the asphalt shingle. You could still use the water. You just don't want to be drinking it. It's too hard to filter the hydrocarbons out. Okay, right button. How many of you get snow 6 inches at a time, 10 inches at a time, and then it slides off your roof? Anyone have that problem?
But not very often.
Okay, it happens to me every year. I lose at least 2 inches a year, 2 inches of water, because roughly 10 to 12 inches of snow is an inch of water. And so I lose 2 inches every year. And if I were worried about it, people in higher elevations maybe, you can install these snow breaks on roofs that will prevent that snow from sliding. If 2 inches is going to make or break it for you, then I definitely consider snow breaks. A little bit about gutter anatomy. They attach to the board that capture rafters called a fascia board. And they can attach in a couple of different ways. They have straps, there are screws or nails, or there's a bracket, but they have to be pretty secure. And then gutters have usually there's a drop or a hole that's 2 or 3 inches in our area, 2 or 3 inches in diameter, that drops into the downspout itself. And so that's kind of the anatomy you're looking at. Rolled gutters, that's where you see the gutter guys, the companies that sell gutters that come out with a big coil of steel, and they fold the metal through a form and they put this 100-foot length metal thing on your roof. That's the best way to go because it doesn't have joints that leak, but you can use section gutters as well. And those are the ones you would buy at the big box stores. So gutter sizing, we're not going to get too deeply into this. I highlighted it on my presentation, but it's not in your copies. Every part of the country has a 100-year storm event average. And our average is 1.3 inches per hour. That's what we expect to get in a major rainfall event in an hour. In the news recently, you might have heard of storms in Kentucky where they got 6 inches in an hour. New Orleans typically gets 8 inches in an hour. Miami is the same thing. They get a lot of rain during a hurricane. And so we're kind of on the low end of the scale, right? But that's the maximum event you want to plan your system for, because if you get that kind of rain, your system should be able to handle it. Worst case scenario, if it doesn't, you just don't get all the water that comes off your roof because your system overflows. It's not the end of the world, but if you want to capture all that water, that's the number you have to keep in mind. And then you know your catchment area, and you consult this really cool resource, which is complicated. So I highlighted where you have to go. And you don't even have to think about this because the stores only sell the things for our area. If we were in New Orleans or something, we'd be over here. Or if we were in Kentucky, we might be here. But thankfully, we're under 2 inches in an hour. And the diameter of our gutters and the size of our roof tends to be right in that ballpark. So if your gutter is sloped at an eighth of an inch, it can carry, that size of a gutter can carry that amount of roof water that comes off of a roof. So you're good. If you wanted to increase the slope of your gutter, you could have a larger portion of your roof served. And if you increase it even further, a still larger portion of your roof can be drained by just that diameter gutter. Okay. So it's influenced a little bit by the roof size, your downspout placement, if you're going to have one at each corner or one for the entire roof. The fascia height, if you have a 6-inch fascia and the gutter itself is 6 inches tall, and you have a 60-foot long roof, at some point the gutter is going to be hanging in air because it just can't drain. There's nothing to attach it to. And then aesthetics. A lot of people don't like the look of something on their house that's sloped. It makes it look like the house is crooked. But if you slope it, it's a more functional for the water supply because you don't have this water standing in your gutters. So for potable water, this is really important. It's required that you slope it a 1/16 of an inch. More is better. This comes from Appendix M, which is what Appendix K replaced. I like Appendix M because it was 3 pages of what you should do. Appendix K is 1 page of references to 27 other pages in the code that you don't have copies of. So it's inconvenient to use Appendix M, or Appendix K, but basically you can't have any. You have to have a 1/16 of an inch slope per foot if you're going to use potable water, use it for potable use. So this is what kind of happens if you don't have something on your roof or in your gutters to prevent them from getting filled. So we have oak leaves, madrone leaves, there's acorns, there's pine needles, there's all kinds of stuff. In fire season, if this is in your roof, what do you think would happen to your roof if an ember landed in that? Right? It's a problem. So gutter screens are probably a good idea, and they're not required in a rainwater catchment system, but they're not a bad idea because they keep all of that from getting into your water supply. So the first thing you can do is put one of these strainers in the drop, and that keeps at least the big stuff from making it down the downspout and into the tank. And there's a couple different ways to do that. They're all effective at just keeping the big stuff in the gutter, but it still doesn't resolve this problem of that stuff decomposing in the gutter and then becoming like tea. And as the water runs through it, the water that comes out is brown colored. So it's very tannic often if it's on oak leaves and such. We call these tea bag strainers. There's another type of system you can get at the box stores. It's simple metal or plastic screen. The plastic doesn't last very long in sunlight, 3-4 years, and they get very brittle. So they're kind of a throwaway. These metal screens have a fairly large hole, so they will also catch pine needles and leaves, which will decompose right on top of the screen and eventually get into the supply. And there's also these fiber screens. It looks like Brillo pad material that you can stuff into the gutter. And it also ultimately functions like a tea bag because material gets stuck in them and the water courses through that material and suddenly your water is brown. What I like to see people use is something like this. Stainless steel. It's not going to burn. Keeps out all the fine debris except for really dust particles and dissolved solids like bird poop. It's very durable, virtually maintenance free. All you have to do is put an umbrella hook on your hose. Have you seen these? And you can, you don't have to get up on a ladder. You just walk under the gutter and just hose down anything that might be caught in this little trough here once a year. Downside, stainless steel is not inexpensive, and water cascading down the roof in a hurry during a rainstorm can sheet right over this until the water tension from the screening material, it's about a 30 micron mesh, can suck that water down. So you might lose some water at the beginning of a rainstorm. Hasn't been an issue for most of the times I've installed this kind of thing, but people do notice that the patio below will be wetter than when they had nothing on there. It's because they've lost a little water. That's where that safety factor comes from, where it splashes off the roof. Okay, downspouts. It's another one of those exercises that you don't want to have to get a copy of this because it's complicated and expensive. But for downspouts, the sizes you have access to in our area are 2 and 3 inch drops. That's the size. And then the actual surface area of the spout may be 4 to 5 inches. But if we have that 1.5 inches or 1.3 inches per hour, that's the size of a roof that a single downspout can drain. And most of us have 3 or 4 downspouts on a roof this size. So we're in the clear. We don't have to worry about this. If we were trying to put a single downspout on a 12,000 square foot barn, that would be a problem. You'd want to look at this chart and size things a little differently. But for residential use, we're doing smaller buildings. If you go to the store or whatever the gutter folks who show up to put gutters on your roof have, or you just get up there and you can see you've got a 2 to 3 inch diameter downspout, you're good to go. You don't have to worry about it. For things get vast gutter screens, how many of us have acorn woodpeckers as our companions out in our properties, right? They're hysterical. I love these guys. They find, I mean, everything is a granary to them, right? I cannot tell you how many gallons of acorns decomposed over a decade that I have found in my gutters. They're amazing creatures. And you want to try to keep that stuff out of your water supply. So there's this. You can put this device, I have one on the table up here, a downspout screen at the bottom of your gutter or of your downspout that has a slope to it that would shed debris but allow water to pass right through the screen. And that's a convenient way to keep material out of your water supply if you don't have those gutter screens up on the roof or up on your gutters. Now, people have gone low tech. I've seen this a number of times. Spaghetti strainer is about the same mesh as the one you get commercially. And this is actually a very effective solution so long as it's not on the top of, you need an 8-foot ladder to get to it because they do need to be emptied periodically. These are pictures of this system, which is available through rain harvest systems out of Atlanta. I think they're about $40 or something like that. They are designed to be used with Schedule 40 piping. So if you're going to be using sewer pipe, you have to get an adapter for it, but you can find those. The lid comes off so it's easy to clean, and they can be painted so they match your house trim, are more resistant to UV light, things like that. It's a great solution if that's the only filtration you have going into your water tank. Around the country, people use things like basket strainers. I don't recommend them because they need to be cleaned out after every single rainfall event, and they're messy. They don't self-clean. And you can get something like this. You'll see one of these on the tour on Saturday, which is a whole system screen. It uses a 4-inch pipe, and water comes in, goes across this surface here, and anything that's going to be wasted, the acorns and things that come floating down the system get deposited here, and the water actually then goes into the tank itself. But that's for commercial systems. I happen to have one because this is what I did, and I had one and I put it on. Roof washers are common. They're really very easy to work with. They're usually made out of concrete. You can fabricate your own or purchase them. Water comes in, hits this baffle, the heavy stuff sinks, and then water flows over the baffle and then is filtered through this. It's usually a stainless steel screen. Sometimes it's some sort of fabric, and then down into a tank of some kind. This chamber has to be scooped out periodically because all that stuff, that sludge that empties there will stay there, and you just want to remove it periodically. But again, it doesn't self-clean, so I haven't had to install one. So the gutter, the screening devices I've talked about, all of these things, the downspout filters and the gutter screens and everything will keep everything out except for dust, pollen, and dissolved bird poop. And that's where you might want to use a first flush system. Someone asked if that was required or if I'd talk about that. Yes, they're required. A first flush diverter is required with potable systems and not for anything else. It's not required on a rainwater system. Question is, how much do you flush? So this is really based on how dirty your roof gets between rainfall events. Do you live near a freeway or a field that is being plowed frequently? There's a lot of dust in the air. Do you live really close to dusty roads where the roof is full of dust all the time? Do you have a lot of trees around you that are dropping pollen on the roof that are constantly getting into your water supply? Those are questions that only you can answer. And typically it's between 1% and 4%, or 1 to 4 gallons per 100 square feet, 10 to 40 per 1,000 square feet. And that's how much water you want to discard in that first flush of rain that cleans off your roof. Now here where we live, most of our dust is in the spring and summer and fall, and then there's no dust in the wintertime because it's raining and then it's dry, but there's no dust produced from roads because they're all wet. And so you really only have to wash your roof off once or twice at the beginning of the season. And then you could probably disable your first flush system if you wanted to do that. So we have a first flush diverter exercise. You take your roof size times that percentage. If you get a really dirty roof, go with 4%. If it's not much dirt, go with 1%. That's your first flush volume. A lot of people are very fond of a low cost tank, which is a piece of pipe. And you can, in your handout, you'll see that any length of 3, 4, 5, 6, up to 12-inch pipe will give you a certain number of gallons. And so if you need to have a 12-gallon system and you happen to have a piece of 12-inch pipe that you can get hold of, you need 2 feet of it and you've got your tank for your first flush system. This is just another exercise on how you would calculate that if you went through that exercise. But I'm just going to show you pictures here of first flush diverters. Does anyone have any questions about the need for these? Yeah. Okay. So here's the one you saw earlier. The tank is actually about 40 feet of ABS pipe. Has a cap on this end with a little tiny pinhole in it. And there's a ball that rests right here when it's dry. And as it fills, that ball floats up to the top of this pipe and it seals against a fitting at the top. And then any water after that first 40 feet of water, which is probably 14 or 15 gallons, any water then goes towards the tank. And that's how all of these systems work. Here's one that water goes through the filter, goes straight down to the bottom of the first flush device, which has got a pinhole in it again. And the ball floats all the way up to this joint where it then prevents any water from going down and the rest of the water is diverted into the tank. And here's one for a very large roof, but it's a very small, very small first flush volume, probably because there's no trees around and there's nothing really to get on the roof. I don't know if this is near an airport or what, but it's just an example of a very simple first flush tank made out of a piece of pipe.
You clean that flush pipe out after every storm?
If the water is clean, no. But if you have an asphalt shingle roof, the particulate from the roof will have clogged that emitter. And that's the only times I've seen those pipes burst is because asphalt shingle grit clogs the emitter, it freezes, the pipe bursts and it has to be replaced. But if you don't have asphalt shingles, you don't have to clean it out ever, or maybe once a year, end of the year, because the water just drips out and then the next storm fills it up.
Isn't there leaves and stuff in there?
No, because you usually have some kind of a screening device.
Oh.
In this case, there's the this gutter screen here takes care of that. In most other cases, you have some sort of a downspout filter that keeps that stuff out. If you don't do the screening, yes, you would have to clean it out every single storm because it'd be full of gunk. Absolutely. Yeah. So there are above ground tanks too you can purchase. These are just, I think these are 35-gallon barrels on their side that could be used. These were done by a company up in Portland called Portland Purple Water. I'm not sure they're still around. I took these pictures probably 12, 14 years ago, but they did a lot of this kind of work up in that area at that time. And then there's underground systems. This is a tank made out of a 12-inch sewer pipe. You purchase these fittings from Rain Harvest Systems, and there's a ball that floats into a seated joint right here. When it's installed, you have water coming down, dropping all the way into this first flush tank. And as the tank fills, the ball floats up to that joint right there. And then all the rest of the water goes towards the tank. This is actually Hope and Neil's system. And then on the other side, once that tank is buried, you see this port that you can access a valve that can empty that tank periodically if you ever need to. There's a pinhole right here. And then you just turn this off, turn it on, empty it once a year. So now we get on to how you get the water from the gutter down through whatever filtration system you have there and into the tank. When we talk about something being a wet conveyance, that means that when it's not raining, the the conveyance, the pipe, is still full of water. It's essentially part of the tank itself. And so as the tank water level rises, so does the water in the pipe. Now, if we didn't live in an area where it froze with some regularity in the wintertime, this would be a great way to go, because you don't have to worry about hitting your head on a pipe that's crossing from your gutter to a tank that's next to the house. However, we do live in an area where you could see these pipes freeze. And so unless you put heat tape on them to keep them from freezing, most of the systems I've worked on have been dry conveyance, which means that when it's not raining, the pipe that goes into the tank is dry. Now you can have dry conveyance systems where the dry conveyance, the pipe is underground, but the tank is usually located many feet away from the house and downslope quite a bit, so that the pipe is still dry when it's not raining, but the pipe could be buried. And there's an example of the pipe before it gets buried, and how you would conceal a dry conveyance if you wanted to pass under it without bonking your head. It's just a trellis. This is of a project that was done in Portland, but it's of a trellis. The pipe comes across that, drops down into the tank. So there's also a way to calculate pipe size, but most of us are going to use 3-inch pipe. It's going to work for almost everybody unless you have 6,000 or 8,000 square feet of space you're draining, and then you're bumping up to 4, 6, and 8-inch pipe. But 3-inch pipe can carry an enormous volume of water. If you slope it at 1/8 of a foot, it carries enough water that would fall in 2,500 square feet. And the greater the slope, the greater the square footage that you can evacuate water from. And the plumbing code has this big chart that gives you all that information if you wanted to peruse it. So tank siting is always a big question because they're big. They can be very big and sometimes a little obtrusive, sometimes a little unwieldy. Below decks has been a common place that people put tanks. I've worked on about 6 systems where that was the place that the tanks wound up. And to access them, there was a port or a hatch in the deck which lifted up. Sometimes there's a latch on it, so it can't be accessed easily. This one had a lock on it, so the kids couldn't get in. And then you just undial those lids and you could get into those tanks, see what's going on in there. That's very common. Below patios is a common place. I've seen 2 systems like this now. I didn't work on, but somebody here in Medford used to make ferro cement tanks that would go under patios like this. These are 3,000 to 5,000 gallon systems. They integrate well, so you can, have things going on like a barbecue and a picnic table sitting on top of them. This is an underground system I worked on probably 10, 12 years ago now, where the client eventually put bench seating here, and they have an orchard down below now, they do. But these are 4 concrete tanks that are all linked together. It's an 8,000 gallon system. And they are able to use that as a recreation area. So it's very functional. Underground is pretty common. It gets to be a little expensive. This is a commercial system that is basically a rubberized membrane that has these plastic grids laid down, and then they seal the membrane. So it's like a gigantic burrito with this plastic grid in it. And then it fills in with water. And one thing I don't like, and then it gets buried. What I don't like about the system is it can't be inspected. I could never get in there to see what's going on. If it's dirty, if it needs cleaning, it's kind of a once and done system. But it's mostly commercial. You won't see this anywhere but big commercial projects. Underground tanks are generally ribbed for reinforcement so they don't collapse when earth is packed against them and they're empty. And they tend to be limited to 2,500 gallons in size. You don't see very often very large tanks available. So if you wanted a large system, you need to link a series of these in manifold. And then above ground, everybody's familiar with wood tanks, right? The beautiful wooden tanks that I remember them from my childhood. The problem though is that when they're empty, the wood shrinks and then there's a crack and then they don't hold water easily. So they need to stay full. Most wood tanks today come with a liner so that if they ever do get dried out, that's not a problem, or they're tongue and groove so that you wouldn't show that gap. You can use rain barrels, and these are all linked in series with the manifold on the bottom there. It's a great solution for urban areas where you can't get a big tank in the backyard. And then a company called Bushman makes these wall tanks in various sizes. They're relatively flat. They're designed for urban areas again, but they think they range from 6,000 or 600 to 1,200 gallons for these tanks. And you can park them right up against the side of a wall in a side yard and still meet those issues that some cities may have about egress in a side yard. If you've traveled in Northern California, Sonoma, Napa counties, you see a lot of this. It's an octagonal precast ferro cement tank that ranchers use for, I believe it's for livestock watering. And these are, I think, 5,000 to 10,000 gallons. But the most common tank that people are using today, and the sweet spot for cost per gallon, are these big plastic tanks. Not necessarily these are both 5,000 gallon tanks. They're called tuna can tanks. Norwesco makes them. But so at this point, if you're buying new tanks, the lowest cost way to put water into a vessel. A little bit about tank anatomy. Pretty much all tanks are going to have a manway cover or an access hatch that is already vented. So you don't have to worry about a separate port. As water rises, it compresses the air inside the top of the tank, and it could cause the tank to bulge unless it could escape. And so there's always a vent in the top of these. They always have an inlet, which is usually 1.5 inches, and that's at the top, 2 inches at the bottom for outlet. They almost never have a built-in overflow. You might have to install that yourself. Whoops, big thumbs. And then they're almost always colored green or black so that algae doesn't grow inside the tank. So that the purpose of that is just to keep it dark inside. And I don't know that there's a difference between green and black. I've never studied that. So tank, go ahead.
There was a question on the chat.
Okay.
About the bangs of big plastic
Bladders,
flags.
right. If you don't have ground squirrels and you have a large enough area where bladders can unroll, and then this is where you attach your downspout to a big empty, like it's an air mattress, except it's for water, right? And it's huge. They make them as big as this room. They would just unfurl, and then you could, and as at the end of the year, you could roll them back up. I've never worked with them. I've explored for one client using them, and we decided not to because they had ground squirrels. They thought they'd chew holes in them, which they probably would. So tank placement, these tanks, this 2,500 gallon tank weighs 800 pounds. So you want to have a person or two helping you roll it around. But saying that, they're really easy to move around when they're on their sides like this. You can roll them. And thank gosh, circles move like that. Steel tanks are something that I wished I saw more of in this area. They're considerably more costly, 2 to 3 times more costly than the plastic tanks. They're usually panels that are riveted together by the manufacturer's crew who comes to the job site to do it. That's part of the cost and why it costs so much. And they almost always have a vinyl bladder inside. So because all those rivet holes are going to leak. So these are, even though they look like steel, they're not actually in contact with the water. There's a bladder inside there that's containing that water. But fire resistant, extremely long lasting, not going to be degraded by UV. Some people like the look of that more than a plastic tank. Can't argue with them. They make them in
life expectancy of a polyethylene tank.
polyethylene tanks. The warranty is generally 25 years, or they give you a 5-year warranty and tell you that it'll last 25 years unless it's under a roof.
Are they repairable?
Not that I know of. Once they become brittle, if they become brittle, I don't know how you'd fix that. If there's a hole in it, you could repair a hole, but a big crack or something like that, I'm not sure how you'd fix that. Yeah, good question though. You can get these tanks up to 150,000 gallons. Anything over 30,000 gallons requires an engineering permit, and that's just a state code issue. These tanks almost always have a concrete pad. At 30,000 gallons, an engineer has to have designed that pad. And again, these are usually installed by the manufacturer's crew. Ferrocement tanks are really popular in areas where labor costs are very low compared to material costs, so not in North America. And because it would take thousands of hours to build one of these, but if you're doing it yourself, this is a great project. And this was done by one of my neighbors who had a hand in building the tank that I have. You have this rebar reinforced pad, which has concrete poured on it, and a keyway is then put in the bottom of that. And then this really cool device here, a lift form, gets slid around that circle continuously until you're built up to 8 feet tall. What results in, this is only a partial picture, because if I step further off, I would have fallen off this edge of slope here. But you'll see this on the tour, is this 8 foot tall, 27 foot diameter ferro cement tank that's 4 foot thick concrete walls that's reinforced with concrete or with rebar. If the time lapse between when these lifts go on is a day or two, you're probably okay. But if it's longer, you'll get cold joints and the tank will leak at each of those cold joints, which is why this tank leaked until we coated the inside of it with a rubberized material. So these tanks can be really effective, but they're labor intensive. And that's the top of what our tank looks like. You can get ferro cement tanks that are pre-cast. Copeland's and Grants Pass makes these water tanks, concrete water tanks. They'll bring them to your site on a truck, crane them into position, and then you can connect them with manifolds, and you can build, as you saw in one picture, an 8,000 gallon tank. They're roughly twice the cost of a plastic tank, but they're also going to keep your water cool if you're drinking it. That's important because they're underground. Tank pads are also a factor when you're designing a system. You want to make sure that the ground you put the tank on can handle the weight. These tanks are pretty heavy. The 2,500 gallon tank, half the size of this 5,000 gallon tank, still has a lot of water in it. And you don't want the soil to collapse so that the tank starts to tilt and starts to break the pipes that you've connected to the tank. You don't want it to move such that it would roll down the hill onto your neighbor's property. And that's why the county sometimes has issues with or wants to see what people are doing if they're putting in big systems. So if you're putting it on native soil or compacted gravel or reinforced concrete, which is required for larger tanks, the tank's never going to move. You'll be fine. Is there a question back here? I saw a wave. No? Okay. Inlets and outlets. I took this drawing, which is in one of the books, and I modified it a little bit, given the practices we see here. So water comes into the tank, and then it usually travels down to the bottom, and there's an upturn, because after some number of years, some of the dirt that comes off your roof is going to settle on the bottom of your tank. And really, you don't want to have the water splashing all the way down and stirring that up. So if you have a way to turn that water force around, have it go upward, that's better than having that all get stirred up. And you only have to do this on your first tank if you have 2 or 3 tanks in series, because this is called the settling tank. The first tank is always the settling tank. Then you have a lot of times people, not everybody does this. I've rarely actually installed these, but your intake is on a float so that it's always in the area that's not where it's going to pick up floating debris and scum that might have got into the water, but it's also not going to pick up any of this stuff. Your cleanest water is in this zone, and that's where you want your intake. Now, if you're just irrigating crops or fighting fires, you don't really care. But if you're drinking this stuff, that's a good place for it. I like my outlets to be upturned at the top, because then I get 3 or 4 more inches out of a water tank. I get more storage, and you'll see a picture of that a little bit later. If we had cut this pipe off right here, the water line would be where that gray line is. And that's got to represent at least 500 or 600 gallons on a big tank. Yes?
That inlet, would you have some way to stop the water from pressurizing?
So the question is, does this inlet need some way to keep water from flowing back out? And usually, the answer is I've never had that happen. It's flowing via gravity. It's usually sloped sufficiently that the water would start exiting the outlet before it went out the inlet. Oh, I see what you're saying. I should have redrawn this so that this was higher too. The inlet and outlet are usually at the same height, or the inlet's higher, but typically my inlet pipes are coming in at a steeper angle than level. But no, it's good catch. I'm glad you saw that. This little arrow of the vent suggests that you don't need a separate vent. Most of the tanks you buy today have a vent built into the lid. So don't fuss with that. And then overflow. The overflow should be directed to somewhere, not the base of the tank, because that will erode the material you put at the bottom of the tank and cause it to slide down the hill. So direct that to a point of beneficial use, like the next tank over, where it can fill that tank up. Okay, there's another image of that upturn at the bottom of the tank. So when you're working with plastic tanks, you don't need really complicated tools. This is just a big hole saw sized for, I believe that's a 3-inch bulkhead fitting that I'm putting at the bottom of a tank. And what's going on here is there's a piece of plywood that I've actually screwed to the plastic of a 2-inch hole. And I've used that because if I don't do that, that hole saw is going to dance all over the plastic and scuff it up and possibly make me a hole that I don't want. It's going to make me a very difficult hole to put a bulkhead fitting on. But once you get that hole off, or that hole enlarged, you can put these bulkhead fittings. I have a couple examples up here. And the bulkhead fitting from the inside slides into that, whoops, another big thumbs. Slides, this is inserted from the inside. This rubber gasket goes over that. And when you tighten this nut, you compress the rubber gasket against the inside surface of the tank, so it's very tight and water won't leak out of it. Usually we go hand tight, and then we use this really complicated tool made out of plywood, just a wrench made out of plywood, to go another quarter turn, just to get it tight enough. Each of the manufacturers of these banjos, one of them, there's 3 or 4 others of these bulkhead fittings, probably has some sort of foot-pound in torque requirement on it, but I don't have a torque wrench that big. So I just go with what they recommend, is just hand tight and then a quarter turn beyond. Now, whenever we install a system like this, we always hire a water truck to come out and fill these tanks with at least to a foot or so of water. A couple thousand gallons of water costs you $100. It's a lot less expensive than discovering you have a leak after you bury these pipes. And then we'll go ahead and backfill after we've discovered we have no leaks. And I think I've had a leak over many, many jobs discovered before we buried it. I should point out this black material right here. Those are rubberized couplings. And you could also use Fernco fittings, which is a rubber coupling. It's not for pressurized use, but it gives the system some flexibility. We live in earthquake country. And what you don't want to do is come out after an earthquake and discover all your water's gone because the tanks were moving and the pipes didn't move in the same direction and they broke. Now, this doesn't guarantee the pipes won't break, but it gives you a little flexibility in the system way beyond what rigid PVC pipe is going to give you. So just about every system I have done has a Fernco fitting, some sort of rubberized or flexible coupling at the joint where the manifold meets the pipe, the tank itself. Now, getting in and out of a tank is an OSHA regulated proposition. It's a confined space. So you want to either do this when the tank is on the ground and you can crawl in when it's laying on its side, or when it's upright like this, have someone else help you. You have a sturdy ladder on the outside and then what's called a single rung ladder on the inside. And it gets you all the way down to the tank floor. It's too tall to actually slip out. And from the inside, that's what it looks like. And you can get inside, clean tanks out, put those couplings in, or those bulkhead fittings in, do whatever inspecting you need. And generally, I've only been in tanks maybe a dozen times. Generally don't have to go into a tank. Connecting tanks with a manifold. I've mentioned this a couple of times. When you have a series of tanks, you have to connect them somehow, and you can connect them in a lot of ways so they function as one tank, one gigantic big tank, or as, in this case, 8 separate tanks or 3 separate tanks. And you can manage your water supply depending on how you connect your tanks. Like this is the month of July, this is for the month of August, this is for September, and this one here is reserved for fire. These have, again, some sort of a flexible coupling. This isn't my project. But it's probably spa hose, which receives PVC cement, some of them. And so if you can use spa hose, have a fitting valve at each one, you can control when you use the water. So in other words, this one could be completely empty. And if all these other valves were turned off, they'd still be full. Or you could leave them all open all the time. and then the tanks would all fill together and empty together. It's a lot of ways to manage these. This is an exposed manifold. I think whoever did this was probably going to bury it at some point. I hope they did, because foot traffic will break these, as will freezing conditions. So what we typically do is we'll put our tanks in at ground level, or pipes in at ground level, and then we'll backfill the tank 8 to 12 inches, about the height of a valve box, which is usually 12 inches. Now, our area, we have a 12-inch frost line, and if we wrap these pipes with insulation first, and we bury them by 8 or 10 inches of soil, not only do we keep the tanks from shifting when they're empty and it's windy, but we also insulate those pipes against freezing. This black pipe here is just a drain from the back slope. I didn't want water collecting in the back. And the soil was pretty gooey, pretty clayey, and I thought if I had some way to drain that and it goes out towards a ditch, that's what that black pipe is. So don't be too confused by it. Okay, and that's what it looks like buried, and there's that valve box right there. Yes,
It looks like those are on native soil.
that's correct.
Did you compact it first?
Yes. Yeah. Not necessary to do, but I like to do it just because it's always a good idea to make sure you're putting those tanks on something that's not going to compress any further. It's, 8 to 12,000 pounds per tank, really. It's a lot of weight.
Well, I'm thinking because we have clay soil also, and when it's wet, it moves all of it.
Yeah.
It seems like in the winter, they might want to sink in.
If your clay soil is relatively thin, and there's bedrock underneath it, probably won't sink very far. But if it was, I don't know, 8 or 10 feet of clay soil like we had in Sacramento where I used to live, yeah, that could be a gumbo problem. Yeah. Okay, so other ways to connect tanks. Oops, again, sorry. You can have them connected at the top. That's an overflow connection where this one fills, then it empties into this one, which fills, which empties into this one, which fills, and then the outlet, it overflows to some point of beneficial use. And each tank at the bottom has a valve. This might be July, August, and September. That might how you think about your water use. Or you could connect them at the top and the bottom. And the bottom connection could be valved or not valved. I prefer to valve them because it gives you more control. And if you had a leak in one of the tanks, you isolate it and you deal with that without losing the rest of your water. You want to make sure that as this tank fills, the volume of water coming into this tank could also escape to the next tank. I see a lot of systems I've been asked to fix them where there was a 3-inch pipe coming in, but a 1-inch pipe going out. And if a volume of water was filling that 3-inch pipe flowing into the first tank, it wasn't going to get through that 1-inch pipe to get to the next tank soon enough. And most of the time what happens is they lose that water out the manway cover, or if they have a vent, out the vent. Not catastrophic, they just don't get the water unless it causes a big erosion problem. But best practice is to always make sure that the way water escapes the tank is the same size as the way water gets in. So if you have a couple of, let's say a 2-inch and a 3-inch line, where's my pointer here? 3-inch line and a 2-inch line here, and there's a 4-inch inlet. That circumference of tank of volume, if you added that area up, would be about the same. You would have no problem losing water that way. But if you don't do that, it's not the end of the world. So outlet options. If you're lucky, your house is somewhat above your tanks and your point of use is 90 feet below, because that gives you 45 pounds per square inch of pressure without any electricity. And I've only seen that once. It's a wonderful situation. I wished I had it. You could have your submerged pump inside of a tank, which is a great way to go because then the pipe or the pump generally won't be able to freeze, especially if the tank is full of water. In our climate, most of the time I leave a 5-gallon bucket of water on my front porch in the wintertime. I'm at 2,500 feet. And there might be 2 or 3 inches of ice on the top, but it's never frozen solid. So I'm pretty confident a 2,500 gallon tank wouldn't freeze either. And that would protect the pump itself. However, if you have a shallow well pump in a building or a setting alongside outside the tank, you want to winterize it because they will freeze and crack. However, this is the most inexpensive and the most common way that people pressurize water is with a shallow well pump that has a pressure tank associated with it, or a somewhat more expensive variable speed pump that senses when pressure is drawn off the system, and it ramps up its revolutions. It's a more complicated machine or motor, but they're really nice. And then some people who are concerned about fire will want to make sure that somewhere on their system they have a fire hose pump that can drop a tube into the water so that fighter fighting vehicles can get water out in a hurry, or they have hose threaded outlets on some of their tanks just so a firefighting unit can pull up and plug in and get ready to go. I'll get a little bit into the threading for that. A lot of us have a combination of all of these. I have a pump that I can put on my tank. I've got fire thread on some of my outlets, and some of my system is gravity fed. And that's true for almost everybody I've worked with. We have a couple of different ways to get water out of that tank. Yes. So would it be worthwhile to have a pressure tank with a gravity fed system? My understanding of pressure tanks is they need to have a pump to pressurize them, which requires electricity. So I don't know if there's a way to do that without an electrical pump pressurizing that tank. Yeah, there's a regulator on the pump that tells the pump to turn on and off as the tank fills and empties. Yes.
We have a 2,000-gallon buried ferro cement tank from our well.
Right.
And we have a pressure pump. It's a 40-foot difference between that and the house. So we do have gravity feed. If the electricity goes out, we only get the gravity feed.
Right.
But the pressure's low, and we have a pressure tank above. So Green Valley Pump is able to do it.
Yeah, so Green Valley's pump is the unit, the guys that I work with a lot too. And there's a submerged pump inside your
Yes.
well
Yes,
tank. And that's what's feeding that pressure pump, that pressure tank that keeps that water at a constant pressure.
But when there's no electricity, we still have water.
They're great. I know. Awesome. Okay, so gravity feed gives you, there was another question. Sorry.
I was going to say, suppressing might be showing up at the engine. If you just have access that they can pump from it, don't worry about it. They can drop adapters in, access. That's definitely.
In most engines carry all kinds of fittings. If they have adapters on board. I've seen their toolkits. I mean, they've got like 12 adapters just in case they run into this situation. So 0.43 pounds is what you get for pressure per foot of elevation drop. This was that site where the 4 tanks were buried in the side of the hill, and there was maybe a 30-foot difference. So they have perhaps 12, 15 pounds of pressure, which is plenty to get water out of a hose to water an orchard, if you want to stand there with a hose and water an orchard. Most sprinkler systems require somewhat more pressure than that to operate properly, but you can find low flow sprinkler devices that will take 7, 8, 10 pounds of pressure. 90 feet is the goal if you can pull it off. Here's a submerged pump in a tank. And what happens here is this arm is floating in the upright position when there's water and the pump is on. And as the arm drops, it switches the motor or the pump to off so it doesn't run when there's no water in the tank and burn itself out. That's how this one works. Here's an example of most of the systems I've worked on, which is there's a pump house associated with the tank system itself. There's a pressure tank in there, a half horse, quarter horse, 1 horse electric pump on the floor, and it runs whenever the pressure switch tells it to run. And that depends on how much you're watering. You can have a float switch inside the tank that as it drops and reaches a certain level, it shuts off the motor so that the motor can't burn out when the tank is empty. Some of my clients have chosen to do that. I still haven't because I monitor my water every day just to see how much we're using. But it's something that I recommend if you're worried about burning out a pump. System you'll see on Saturday, if you're going on the tour, is water comes off the roof through that little filter right there. There's the first flush tank, which they've disabled because it kept freezing and breaking, and passes into the tank where both of these tanks supply water underground into this pump house. And that's what it looks like from above. It's insulated because it gets cold there. There's a very small, I think it's a quarter horse pump with a very small 5-gallon pressure tank, and passes through another type of filter called an amiade filter, which keeps the things out of water that would clog your emitters, because these irrigate a garden and they don't want to have to change out their emitters every few years. Here's that fire hose thread. And those are the standard sizes. My friend Rich Fairbanks, who's a retired firefighter, tells me that these are the sizes that initial assault crews are likely to have. This is the size that the fire department is probably going to roar up to your house with. But all of them have adapters, so don't worry about it. This is his system. He uses his strictly for burn control. He does a lot of pile burning and controlled burning on the side. So post-tank filtration. If you're watering livestock or for flood irrigation, or you're concerned about fire protection, you don't need to do any post-tank filtration whatsoever. Whatever comes out of the tank is good enough for that application. If you're drip irrigating, consider these amiade filters, and you'll see one. I can maybe even take it apart for you on Saturday. If you're drinking the water, it needs a great deal more work. There's usually a coarse filter, a micron filter. One of these may or may not be charcoal and ceramic. They have to be occasionally replaced completely. And then you need a UV filter, which by the code requires replacement every 6 months. And the UV kills whatever bacteria and such that might have passed through these other filtration devices. If you are in a place where you don't have drinking water because your well's gone dry and you can't see paying someone to bring 2,000 gallons of water to your house every week, this kind of thing makes a lot of sense. But last time I did one of these, it was something like $8,000 to install the system, and there's a fair amount of maintenance involved. If you don't have any other choices, this is a great way to go, but I wouldn't do it just because it's a good idea. There's another one of these amiade filters right here. Okay, so overflow. I think we're getting towards the end here. Overflow. This is where tanks flow from one to another or to a point of beneficial use when all the system is full and you just have more water coming at you than you know what to do with. You got to find a place for it. I like to get as much water in a tank as possible, and if I had just let that be the level of the overflow, that's 3.5, 4 inches of water that I wouldn't have in this tank. So I take a fitting, an elbow fitting, and I just turn it up and glue it at that end, and I just get an extra 4 inches of water out of a tank. It could be hundreds of gallons, which for some people is a lot.
Mice and debris.
Well, there's a lid on these, so they're closed all the time. Well, on the outside, they would be screened, so things can't crawl up the tank. Although if you don't screen them, I'm thinking probably things could. But these lids are almost always sealed and usually locked, because we get into this in safety, but an open tank and case law in some states is an attractive nuisance. You don't want kids climbing in there and not being able to get out. So here's an overflow system right here, where at the very top, water comes out, goes down the hill, where it ends up in a dry well. It's a 3 foot, 4 foot deep well, a couple of feet in diameter, lined with hardware cloth, so burrowing creatures can't fill in that rock bed. And the velocity of the water coming down this hill is broken up by all these rocks. And while the water may bubble to the surface, for the most part, it stays in place and it just infiltrates at the bottom corner of this lot in Talent. Whenever you have overflow, you want to find a beneficial place for it to go. That's not going to cause erosion. And the trees and bushes that live near that overflow will think they've moved to Coos Bay. Couple of safety issues. You're going to be digging. Always call the dig hotline. because you don't want to, if you think you have a day-long project ahead of you and you hit wires, it's a lot longer than a day. Again, the confined space guidelines don't go in a tank alone. Make sure unless it's on its side, and you can just crawl back out and be safe in there. Lock them if you can, or just don't leave ladders leaning up against them. There is a requirement, I think the next slide goes into this, that rainwater pipes can be identified by spray painting them purple, or by buying tape on them that say rainwater and just taping them to the pipe. So 20 years from now, someone's digging, they hit the pipe, they wonder, oh my God, what is this? Oh, it's rainwater pipe. We'll just reconnect it, not pressurized, not a big deal. Whenever you have a faucet that's non-potable, you should identify it so people don't drink it. May not hurt them at all, but it depends on the condition of that water. So caution, put non-potable water, do not drink is sufficient. There may be something in the newest code language that prescribes what you should say, but this is what I've always put on my systems. Maintenance, keeping your gutters and roof clean is critical to keeping the water clean. Maintain the filters once a year. If you have a lot of pollen, a lot of leaves, a lot of things like that, maybe twice a year. Check your first flush if you have one fairly often, especially if you have an asphalt shingle roof, because the particles in the asphalt shingle that get into that will plug the little weep hole. And if you get a cold night, you might have some cracked pipes. Monitor your water level if you don't have some sort of a low flow indicator to tell the motor not to turn off. And then check for leaks periodically. It's not difficult to do. Usually you'll notice if your tank's dry and it was full and you hadn't turned anything on. But sometimes you'll see it leaking out the side of a drain pipe or something. And if it's for potable use, there's a prescribed regime that the state requires you go through to make sure that your water is going to be safe to drink. Now, just a bunch of pictures of different systems throughout this area. This is a system over on Pioneer Road that was initially just the 2 tanks. It drains, I think it was a 4,000 square foot roof, comes down the hill. The conveyance is actually dry for most of the way. In other words, the pipes are dry beyond a point right about here underground, because we brought them in underground because it was the convenient thing to do. But from about this point up to the rest of where the house is, whenever it's not raining, those pipes are dry. Anyway, they wanted to add more water storage. And so a few years later, we just added 3 more tanks. And whenever I design a manifold, I always stub out the outside end, anticipating that that might be something someone wants to do. This is the pump pressure tank house, which was electrified. They already had electricity near their well, so they pulled power from that 20 feet to where this location is. So it wasn't they had to pull a permit, but it wasn't expensive to do it all. And that's into a clay hillside with gravel that's been compacted for a base. Another expansion, somebody installed these Bushman tanks here 10, 15 years ago. Client wanted to double their storage. It was too narrow an area for us to get a backhoe in. So my crew happens to be the Suda trail crew. They knew how to excavate trail. And so we excavated this 16 by 8 foot space on this hillside and parked these tanks after compacting this gravel and doubled the system volume. There's a system that is, that's actually my system, a little more close up, taken a few years ago. There's another building in the picture, but you've got roofs. All of this water from here and another building that's there now, right here, goes into a tank in the garden called a surge tank. And then from there, it gets pumped up to this big ferro cement tank, where it gets pumped back down to the garden, where we've got 20 fruit trees and vines and couple thousand square feet of berry beds and such. And if you're thinking Rube Goldberg could have done this, you're right. But sometimes you get that where your roof is lower than your tank and you want that water has to go down before it can go up. And it gets a little complicated, but it's all doable. It's a little bit vulnerable in case one of those pumps goes out and I don't know it, then the whole system fails. The simpler you can make these, the better off you are. But sometimes you just can't control that. Could I do it all over again? I would have purchased this piece of BLM land right here, built my house up there, water would have drained into that tank and it would have gone by gravity into the garden. I wouldn't have had to use electricity at all. But the BLM wasn't cooperative. System you'll see on Saturday. We've seen this already. That's part of their system. They too wanted to expand it. And so a few years later, we added this series of tanks to collect water off of the roof. And we didn't want to pull an electrical permit. And so what the client does is when this set of tanks is empty, which is permitted to push water all the way to their garden, they get out a portable generator and a little trash pump, and they attach a garden hose to it, and they open up this box where there's a faucet, and they turn on that generator and that pump, and they pump 10,000 gallons from here up to these two empty 10,000 gallon tanks, which are connected to the system they spent all the money with the plumbing and electrical permit on. And I thought that was a great way to go. They didn't have to get it, there were no permits required for this lower system. Again, we've seen the system once before. It's a small 500 gallon tank in Talent with room to expand another 6 or 7 tanks should they want to do that. Small job we did in Medford, rain barrels that were watering a bonsai garden area. And what's unique about this, this is a system. You purchase these downspout filters from a company. I'm not sure where they got this. This is what they had when I got there. They wanted to expand it a few tanks, but also make it, prevent it from freezing in the wintertime. And so what we did is we put the valve that turns each of these tanks separate from each other inside the tank. To access it, they have to open the lid, use this device to turn this valve. Right now it's in the off position, but they can see down it when it's full of water. And then they would open this, and all the water that would be exposed to freezing drains out of the manifold. And then it's fine to go through a cold snap.
So it drains out just because you've got, it's not pressurized, but I mean,
Gravity, right? The question is, it drains out. If it's not pressurized, how does it drain out? The gravity flows. Yeah. You'll see these Fernco fittings again, these rubber couplings that give it some flexibility. So in case anyone steps on this, I think they put a plywood plate or something over this to keep it from being degraded by sunlight. But and they could also wrap it with insulation if they wanted to. But these Fernco fittings, rubberized couplings, give it a little bit of extra flexibility. System up on Elk Creek, which is a potable system. And at the time, potable systems required a concrete pad. I don't think that's the case anymore, but 2 2,500 gallon tanks. The client was going to build their own pump house right here. And then the plumber they hired installed the filtration system across the meadow at their house where their house is. But we had to add a fascia to the side of this pole barn and then make it deep enough so we achieved that 1/16 of an inch drop over 60 feet. And then we had to have the first flush and all those different things. And there's stainless steel screening on this and all that, all in the code, but this is for potable water. I think their issue had to do with poor well production. System out in the Applegate, used strictly for watering horses in the wintertime. Client did not want to be carrying a 5-gallon bucket a quarter mile down an icy road every time they had to water the horses. So this water comes off of both of these roofs, goes there's with the stainless steel screening on them, drops into the tank, and then there's the overflow. And there's a faucet right here, and they just put a bucket under that, take it to the horse stall, everybody's happy. They can knock out this wall right behind here and put 6 more tanks in there if they wanted to collect water from the rest of this barn roof. This little surface here was enough to cover the 2,500 gallon tanks, but not much more than that. Okay, I think a lot of this was already covered, if I'm not mistaken. I'm recommending that people carpool because there is not a lot of space at these locations. And what we don't want to do is spend the first half hour of a 45-minute visit just jockeying around with cars. So carpool if you can, meet at either at this location somewhere in Jacksonville, like the library parking lot, or at Buncombe, if anybody knows where Buncombe is, little ghost town at the intersection of Little Applegate Road and where Sterling Creek Road ends. People park there all the time. Pack a lunch at that second site. That's where we'll be having lunch, and I'll have cold refreshments, lemonade, such things like that. If you're wondering where this is, it is right in this area here. And I borrowed a map from the BLM because all the locations are on it. It's a trail map for the Sterling Mine Ditch Trail, but the locations are all really close together. I think we're 2 miles away from this one and half mile from that one. We'll meet at this one at 10 o'clock. And by 11, we'll have started going to this one where we'll have lunch. That's my location. And around 12:45, we'll just cross the street. Whoops, big thumbs. Okay, I think it's decided it's ended. We'll cross the street and go to the last location to be finished by 2. And the next slide was, are there any questions? Yes.
Early on, you mentioned floodplain, it was kind of a different conversation.
Yes.
Could you maybe give me a little details on what that means?
I cannot. The building code, because I've never had a project in a floodplain. The building code requires that you have that process reviewed. So when you go to is it in the county or a city?
It is up in Wyoming.
So probably county.
Yeah,
Okay.
definitely not the city, yeah.
So you talk to the folks at the county planning desk. There will be a desk charge for that. I think it's $125 to put your plans on the table and talk with them, and they will tell you all about that.
Jim, can you repeat the question?
Oh, the question was, if you're planning to do this in a floodplain, what's involved? And the answer is, I really don't know. I've not had to deal with that
Maybe what
before.
we need to do is, would it be possible to have your
Okay, we have technology. This is great.
The main idea that I was asking about is if we want to create a pond on our property, would we be able to have our catchment system feed into the pond at some point?
That's also a good question. I've never had to build a system where a pond was involved because I usually dissuade people from storing water in a pond because you lose an inch of it every day. The temperature is over 90 degrees. So if you have an 8-foot pond, it doesn't take very long before there's nothing in that pond.
Once it reaches the pond, that would be its kind of final resting place just for the sort of the ecology of the
Right.
property.
Right. If you put it in a tank first and then it winds up in a pond, that's a different story. That's a different story. But if you take water from your roof and put it in a pond, I've never had that question. It's a good question. The water master would be a good person to answer that question. Siobhan Haynes is the water master here in this county. He'd be an excellent resource for that. Yes.
We have talent.
Wait.
Sorry,
Don't make Rachel run.
Question from the
Thank you.
audience.
We have talent irrigation district. The reason we're interested in rain catchment is last year they ended the irrigation season way early and everything went pristine and our well couldn't deal with it. Can we only need it for irrigation. Can we just save it until August? In the tank?
Save rainwater in the tank?
Yeah.
Oh, sure.
Okay.
It might be warm,
Yeah, I don't think
but
the plants care.
yeah, no, really, the plants do not care, I'm sure.
Right. The other thing we can do is we can do a slush pond with Talent Irrigation District. It's quite expensive. It would involve the same kind of rubberized tanks, but we cannot mix the systems because the slush pond has to be emptied 2 weeks after the irrigation season ends. So, okay, we get an extra 5,000 gallons, thank you TID, but we still need the rainwater.
Doesn't help you, right?
Okay.
Yeah.
So I'm not sure if there was a question in there. I think it was,
It was a
can
good,
it,
it was
can
a
it wait?
good point. There's a lot of nuances to water use in our area, especially when you're trying to blend irrigation systems with rainwater. Yes.
there any restrictions at all to what you can use the rainwater for, as if you use it for a commercial orchard or vineyard or something like that? Or that then come under the purview of the water master?
If it falls on your, I've never had this question, but I'm guessing that if it falls on your roof, whether it's a residence or a commercial operation, it's your water. And you put it in a tank,
Yeah.
it's your water.
I talked with water master there.
Yeah.
That's the same way.
Other questions? In the back. Make Rachel run.
With the steel tanks with the vinyl bladder inside, have you ever heard of that bladder being replaced or needing replaced over the years? Does it degrade?
Yes. I have heard, everybody heard the question? Okay. I have heard that sometimes the vinyl bladder rubs against the inside of the rivets, maybe as the tank is filling and emptying. Possibly in wind if things are shifting back and forth, and there can be some abrasion that cause the need to patch the bladder. I think patching is more common than full replacement, but ultimately it's vinyl, it's not that thick, it probably does need to be replaced periodically, but it might be 10, 15 years. I've estimated a number of jobs with steel tanks, but the clients always not purchase them because it's expensive.
Sealing it with
Sealing of, what about sealing what with silicone? So there's a couple of thousand rivets in those tanks. I don't know that silicone would do the job, to be honest. But I don't know. I've never tried that.
Thanks, Greg.
Place between the liner and the tank itself, because when we had an above ground pool, they used a foam pad for line around that for a cushion for like kids.
Right, right.
That seems like that would be a good.
And there may be manufacturers who do that. That's possible. Yeah. Just before Annette asks her question, I'm going to say a word about putting buffers around tanks. Someone asked earlier about how long does a polyethylene tank last. 25 years is the life expectancy if they're in the sun. You can put stucco over a plastic tank, and that would also prevent it from melting in a fire. I know a lot of wildfire people have come up to a property with a water tank and seen the tank melted down to the water level. You can do that. But you have to wrap it with a mesh and then coat it with stucco, and then it would be fire repellent. Fire would likely melt. Embers could land on it, wouldn't cause the tank to melt. If there was wood stacked up against it, all bets are off. But you'd also get a much longer life out of that tank. You would, though, recommend that you put a fiber or it's a fibrous material that's used in the stucco trades. That would give you some buffer, because when the tank is full, it swells and then it shrinks, and that would cause the stucco to crack up quite a bit. Annette.
Can you hear me? If you have a 2,000-gallon concrete tank, do those ever need to be cleaned out or serviced in some way?
Yes, if they're going to be used for rainwater. Is that what you're asking?
Well, that would be one, but what if it's used for household water?
So your well water is there, right? You're supposed to if you're using a concrete tank and that's where your well water goes into, you should be periodically cleaning them out, having the water tested. I think they recommend once every 5 years. I don't know what the protocol is, but it's not a bad idea, because stuff gets in those tanks too, even if it's just from your well.
I had a question. The first question, do they always have a fall in it, or are there designs that you can make yourself?
I'm not sure I followed that, Monty. One more,
So the first flush diverter,
right?
you said they have a ball in it that rises.
Got it. Okay.
Do they always have that ball?
They don't. The ball prevents turbulence So if the ball isn't there, the water will still bypass that surface because that tube is already filled. But research has shown that the turbulence drags some of that dirty water into the tank with it. The ball's not critical, no. It's just that when you buy these things from various sources, they always have a ball, which if it freezes, crushes up into this crinkled little thing, like if you'd stepped on a ping pong ball. That's what it looks like. That's when you know that the thing is frozen. And you can take a compressor and reinflate them. There's a little hole in them. More questions?
There was one online.
Okay, one online.
There was one online. Okay, there was one online that was a question about source for industrial sized gutters. Back when we were talking about gutters.
Yeah. I've not sourced them in our area. Usually you can get a couple of different widths from the folks who have those coils on the back of their truck, and they'll make you a K gutter or a pan gutter, different sizes. I don't know where you would get them locally, but it's basically metal bending. And if you are not needing continuous gutters, just metal bent to be the shape of a gutter, and you found some way to connect them at their ends, they're usually going to be 10 feet long, and any metal bending shop can make you gutter material of any shape or size. But I'm guessing that commercial buildings often have much larger roofs, and if they have gutters at all, they have much wider gutters than the little ones we see in residential construction. I just haven't had to source them here. Good question.
If you use some of that water for drinking water, system to
Right. So if you're merging, the question is if you are merging, I think the question is if you're merging a well water system with a rainwater system that supplements the well water when the well's not producing, do you need to have any type of backflow arrangement so the rainwater doesn't contaminate the well water system? And the answer is yes. And it's complicated. It's actually a double backflow thing that I've always had my plumber, who is now Jackson County's plumbing inspector, take care of for me. Thank you, David Kennedy. And it's not terribly expensive. It requires annual maintenance, but you do want to keep those two systems separate, correct?
That's it.
All right. Oh, one more.
Recommendation on tanks and barrels?
So there's where to get them?
Yes.
So not long ago, tanks were going for about $1,000 per 2,500 gallon tank. And this was such a great deal. I wished I'd bought a truckload of them. I mean, 10 truckloads of them. Right now, they're going for about $1,800 for a 2,500 gallon tank. They've gone up considerably due to probably some sort of supply chain issues related to COVID. I've seen them come down a little. I have a client who recently doubled their system size. They were watching Joe's List or Craigslist or something, and they found 3 tanks for $1,000, 3 2,500 gallon tanks for $1,000. They just had to go pick them up. So you can find used tanks for a pretty good deal, but new tanks of that size there's 3 or 4 plumbing outfits in town. All the box stores sell these tanks. The folks over at Daisy sell tanks. Yeah.
And rain barrels?
Rain barrels, I've only ever seen rain barrels up at Coastal. What's Coastal called now? Is it called? It is Coastal. It used to be something else. Yeah, Coastal has, I think they're 35 or 40 gallon rain barrels. They might be in other places. I just haven't seen them. I generally don't do that many small systems. Most of my systems are 10, 20, 30,000 gallon systems.
I just have one particular downspout that has to have the rain barrel because the area is not big enough for a tank. So.
Right.
Can you ask on the tanks about rib versus just the smooth sided?
What's that?
Can you ask about the rib tanks versus the smooth sided tanks? Is one stronger than the other?
Yeah, I guess.
Well, the question was, are rib tanks stronger than smooth walled tanks?
Yeah, right.
And the answer is probably, I don't know. The ribbing may be just a way that the manufacturer wants to brand their design so everybody recognizes it. I mean, Bushman puts these convoluted flutes in their tanks. They look really cool, but I don't know that they're any different than the same size Norwesco tank, which is smooth walled. When they're underground, however, that ribbing reinforces against the pressure the soil exerts on an empty tank. So if it's going to be placed underground, the ribbing, if it's designed for underground use, is essential. And if it's not going to be underground, I don't know, probably not.
Option, the rain barrel, how about the square ones? I think they're called IBC.
Yes, IBC totes.
Like frame around it.
Right, right.
That works, right?
So except for the fact that they're usually clear plastic, and so sunlight would cause the water to turn green eventually. They're a pretty low cost way to store water. Yeah. If you can paint them, then that would be one way to keep that water from turning green. Yes. I will say though, that if you have, what are those 100-gallon, 200-gallon IBC totes? What are they?
Normally 275.
275. So if you had a bunch of 275 IBC totes, that would be 10 to give you about the same amount of water as one 2,500-gallon tank, which is an $1,800 investment versus however many dollars you spend on that many IBC totes, and all the fittings that you don't want to leak. So the more complex your system, the more prone it is to failure. Put that out there.
My turn.
Your turn.
Now, situation where you have two downspouts. Planning on feeding one tank. We need two for those first flood filters. Or can you form it in such a way that you can get away with just one?
Yes to both versions of that question. You might need to, depending on how far away the tank is from the downspout. I've been in situations where they were so far away that losing that 1.5 feet downspout drops into here. You got a pipe and it has to make a turn. Maybe it's 1 foot. Losing that 12 inches meant that the water wouldn't go to the tank. It would have to flow uphill to the tank. So I couldn't put this unit at the gutter. I had to put it somewhere else.
I don't have that problem.
Okay. So you could get away with just one, sure. If your roof is small enough that you're using 3-inch pipe, you'd have a Y that would come into whatever device you're using for a screen, and then this would go into your tank.
Okay, thank you.
Other questions? There's some things on the table if you want to take a look at some of there's some various types of gutter screens and this bulkhead fittings books. If you want to take a look at those, I'm happy to answer questions. There's more questions. All right, one more question.
You mentioned, so I was costing things out with using 3-inch Schedule 40 PVC pipe. It
Right.
sounded like you said there's cheaper options. I mean, I'm gonna have probably 500 foot of piping to collect off multiple buildings. What's kind of the cheapest pipe that I could use?
It would be drain waste pipe, white drain waste pipe, but none of the fittings designed for rainwater collections fit that. So you have to use Fernco couplings everywhere, or find some PVC pipe that some fittings, some couplings just happen to have the outside diameter that fits Schedule 40 inside diameter. There's a fitting I pick up at Home Depot, for example, that just happens. It's just luck that it does this. But for the most part, if money is really, really important, then go ahead and use strain pipe. But my feeling is Schedule 40 is a better way to go. It's more durable. It's less likely to get hit by a shovel and break. There's just so much recommending a thicker, higher quality pipe on a job that I don't want to have to do a callback on. think we finished before 8 o'clock.
Okay, I just wanted to remind folks, if you're going on the tour, I sent the email and it had a doodle, which some people have been struggling with. That was just so that we would have an idea of how many people, because he prefers there aren't 30, but so far we have 18 people who signed up, so I think it's not gonna be a problem. If that doodle poll hasn't worked for you, just go ahead and show up. I think that the capacity is gonna be fine. And the carpooling, I also gave you a link and sent the addresses of the sites you're gonna see and a link to a Google map. You can just make a Google map yourself. If that link doesn't work, you can get there. If you wanna meet here to carpool before, you have to calculate from here. In my map, it has that time frame, but you have to calculate your time to meet here beforehand and then head out. So that's carpooling. But otherwise, thank you. That was, yes. I'm sorry, Saturday. I mean, it's tomorrow, but Saturday is the tour. That's what I'm saying, that wasn't arranged. So if I sent a map. I mean, I can try and send that again with a calculation for people to meet here and what time it would take. I didn't figure that out for you all, but I just gave you what the information I had from him, so that map is there. So I'll send another email with that calculation, but I'm not coordinating the carpool. It's up to you guys to
Rachel,
come
just
and
tell us to
go.
talk to each other now.
Yeah, if
You
you,
can talk to each other right now.
if you want to carpool, agree to meet at, it's about a half hour, let's give it 45 minutes from the Jacksonville Library parking lot to the first site. So if we were meeting at 10, then at 9:15 or 9 o'clock, be at the Jacksonville Library parking lot. And if you recognize each other, you can pile into, a car or two and caravan out to the first site, and then that's all where you'd come back. You could also meet at Buncombe, which is less than 5 minutes from that first site. If you know where Buncombe is, it's this little ghost town, 3 buildings on a corner. People park there all the time. It's another option for you. Right.
Yeah, I'll be at one. I'll be meeting people at one.
Will anyone be at the library? Or is it 9:15? Buncombe is just fine. So
Yeah, it's,
if you drive by and you notice that there's Buncombe and there are cars there, you can stop and jump in another car. It's pretty obvious. If you haven't been there, you'll see it when you go by.
yeah, the fewer cars, the less time we'll spend figuring out how to park on the road and walking hundreds of yards to where we're going to talk. The fewer cars. So fewer cars is better, but if you have to come alone because you just come from way out there, we'll make it work. Thanks so much. This has been a lot of fun. I hope you enjoyed this. See you guys.